Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In this video, I will explain Kirchhoff's first law. Kirchhoff's first law is also called KCL. In this video, my plan is to make KCL super clear to you. Watch video carefully and develop your understanding of KCL.
For example, if I talk about node, actually, a node is simply a junction of connecting wires. And this is one thing, a junction of connecting wires. So we need to understand is junction of connecting wire. The second thing we need to understand about node is that every point on the node is at the same potential, means the same voltage. So if you look at this point, you can see here, this is. So this is one node actually. This is a one node. It's a junction between these two wires. And also this is also node, example of node. So this is example of node. And here if you look at this one, this is also an example of node. And the bottom one is little bit tricky actually, but if you can see this one from here, you will see all these points are at same potential or voltage. So this one we can also describe as a node. And the branch we need to understand, branch is just a fancy name. It's just a fancy name for a circuit element between two nodes. Now you see we have one node here, we have another node here. So between these two nodes we have a circuit element, and this circuit element we call this is a branch. So this is branch. You can also see here we have node here, we have node here, and between these two nodes there is an other circuit element is attached, and this one is also, we can call this one is a branch. And if you look at this side, you can see here, so this is also one circuit element and it is between these two nodes. So this is also one example of branch. Now the next thing we need to understand is that what is a loop? Loop is simply a closed path. It begins and ends at the same node. So what exactly it means? Simply we can understand. Let's say we take example of this node. So if I start from this node, begin from here, go this side, and if I come back to the same, for example, it started from here, I went this way, and finally I came back to the same node or same point. So this rectangle you can see here, so this is a one loop. So this is, we can say this is one loop. So if you also look on this side, so this, if you go this way, come back and at the same point, so we can say this is another loop. So this is also an example of loop. We can also do like this, we can start from here, we can go like this, and we can come back to the same point you can see here. So this is also loop. So we have another loop, so that one we call is, this is also loop. So what exactly is Kirchhoff's first law? Kirchhoff's first law is very simple. So let me explain to you with one simple example. First of all, let's say we have one circuit here. We have two resistors, and these two resistors, they are connected in parallel. So as you can see here. So as, let's say this resistor is R2 and we have resistor, this is R1. And we have power supply. Let's say the EMF of this power supply is equal to V0. And the total current in the circuit is equal to I, and the current entering into this branch is equal to I1, and current entering into the second branch, that is equal to I2. So according to Kirchhoff's law, what Kirchhoff said was that the sum of the currents into a junction has to be equal to sum of the currents out of the junction. So it simply means that I entering at any junction, so we also need to be clear about that. At any junction, at any junction, at any junction I entering is equal to I leaving. I entering is equal to I leaving. So what it means, you can see I entering at this junction. If we look at this junction, I entering is equal to I leaving is I1 and I2. So this is Kirchhoff's law, means I entering is equal to I leaving. We can also understand this one with another example. So now you can see here, in this example, you can see this is a junction actually. So we can see I entering is I1. So this is I entering and this is also I entering. And I leaving, we can see this is I leaving and this is also I leaving. So we can write down according to Kirchhoff's law. So in this case, I1 plus I2 has to be equal to I3 plus I4. And this law is based on conservation of charge, and sometimes in multiple choice questions, especially in paper 1, they will ask you about this one. So you need to be clear about this. To answer this question about Kirchhoff's first law. So the question, first of all, you need to understand what question is asking you. Question is asking you, you need to prove that Kirchhoff's law is satisfied or not. So let's try to answer this. So first of all, we need to understand Kirchhoff's law. Kirchhoff's law, we have discussed that at any junction, as you can see here, at any junction, I entering has to be equal to I leaving due to conservation of charge. So I leaving. So here we have I entering has to be equal to I leaving. So now we need to find out where is the junction. Junction is here now. So I entering. So entering, this is entering. So I will just use red color. This is entering. So this is also entering. I will just use red rectangle for this one. And also you can see this current is entering, means is flowing into the junction. So we can write down all here. So I entering, you can simply say we have 3.0 amps, plus we have 2.5 amps, and plus we have 1.0 amps. So the unit for all of them is amps. So I'm just writing numbers to make it a little bit simple and look nicer. On other hand, we need to understand is that I leaving. So this is I leaving. So we can say is leaving this junction, and also you can see this is also I leaving. So, and if we look at this one, this is also I leaving because it is coming out of the junction, means flowing out of the junction. So now we can write down here. So we have 4.0 amps leaving and we have 2.0 amps leaving, and also we have 0.5 amps leaving. Now if we add actually on both sides, what we will get 6.5 amps on the left side, and we will also get 6.5 amps on the right side. So question was asking you, is Kirchhoff's first law satisfied? So it is satisfied. It is satisfied. So simply you need to say that Kirchhoff's first law is satisfied. Satisfied. That's all for Kirchhoff's first law.